Good morning, my dear students. Today we are going to learn another activity, that is what happens when a light train travels from denser medium to rarer medium. This is activity number 4 in the textbook, and let us see an activity for this. So that is, take a plastic pro circle. This is a plastic pro circle. The plastic pro circle is nothing but a 360 degrees protractor. So generally we will have a half protractor in our geometry box, but we are just using a 360 degrees protractor. It is called take a plastic pro circle, and it will have angles on it. Here this is called 0 degrees, and here so on this plastic pro circle or 360 degrees protractor, it has angles on it. From here to here we know that 90 degrees, and here to here we know 180 degrees. So that is, again I can write it as 90 degrees also. So means if you come from here to here, this is 0 degrees, and again here to here, so 90 degrees. Okay students, so that is totally 360 degrees. Take a plastic pro circle, adjust 2 strands on it. So adjust 2 strands on it such that they can be rotated freely. So means this is one strand fixed at the middle of the 360 degrees protractor, fixed at the middle of the 360 degrees protractor with a pin, and this is a complete 360 degrees protractor or pro circle. So this is what students? Pro circle. That's called plastic pro circle. Fine. So one straw I fix here. So this is and another straw. And this is the another straw. Okay students, and we know that these are what? Straws. These are the straws. So fixed at the center with the help of the adjust 2 straws at the center of the pro circle, such a way that they can be rotated freely as shown in the diagram. Means the straws are set like this as shown in the textbook. So see students, this is the 360 degrees pro circle. This is one straw, colored one, and this is another straw, and they can rotate very easily, and you can fix for any angle as you want. That is the first step. Now adjust one of the straw. So this is the adjust one of the straw which makes an angle 10 degrees. So adjust one of the straws which makes an angle 10 degrees with this normal, with this line. Now immerse this pro circle vertically into a vessel So I am immersing that pro circle. This is our pro circle. So immerse this pro circle vertically into the water. So I am immersing this pro circle vertically into the water filled in a transparent vessel. This is a transparent vessel and we have a water in the vessel. So this is totally a water. So we have full water in this vessel up to this level. So fine. Then while immersing this pro circle into this water, see that the straw which is making an angle 10 degrees. So you can call this as the first straw and we can call this as the second straw. While immersing this pro circle into the water, see that the straw which is making an angle 10 degrees must be inside the water. So this straw is inside the water. So this is the straw which is inside the water. Now look the straw from the top of the vessel as shown in the figure. Look for this straw from the top of the vessel as shown in the diagram. So while observing and when we look at this straw from the top of the vessel as shown in the diagram, so this is eye level and we are looking this straw inside the water. So from the top of the vessel, obliquely we are looking and adjust the outside straw in such a way that they both appear in a adjust the outside straw until both the straws appears in a single straight line. So outside straw we have now, this is second straw. So we know this is the first straw and this is the second straw. We are rotating this. Here it is, we are rotating. So when we can see this straw when the light rays from this straw reaches the eye of the observer. We can see this straw inside the water when the light rays from this straw reaches the eye of the observer. We can see any object inside the water when the light rays from that object reaches our eye only. So see, this straw is in water, this straw is inside the water. So the light rays coming from this straw initially traveling in water means they are traveling in denser medium. The light rays from this straw coming from the denser, and this is the interface surface we know, and this is the interface. This is the interface surface, and at this interface surface the light rays coming from denser tube. So they are entering into air medium. So that is rarer medium. What happens? So they will bend away from the normal. So the experimental result is that the light rays coming from this straw at this point of interface bends away from the normal. So and they will come like this. Means if you extend the light rays backward direction, the straw will appear, this straw will appear for us here, and by looking the apparent position of the straw, we are adjusting the outside straw. This is a inside straw and this is outside straw we are adjusting. Then take the pro circle out of water and see that both the straws are in the same straight line or not. We will find that they are not in the same straight line. The reason is the light rays coming from this straw bends away from the normal. If we consider this is the normal, bends away from the normal. If we extend those light rays backward direction, the light rays appears to come from here. So the straw inside the water, that is the first straw will appear for us here inside the water when we look obliquely as shown in the textbook like this. This straw will appear for here us. That's why we are adjusting outside straw. So in such a way that both the straws adjust the outside straw until both straws appear in the same straight line. So we are adjusting into the same straight line we are adjusting. So it will appear for here even though the original straw was here only, but when we look obliquely the straw will appear for here. So we have taken out the straw and we are seeing the pro circle. Take out the pro circle and see the two straws on it, they not appear in a single straight line. So the reason is, this is the reason. So because the light rays coming from the denser to rarer bends away from the normal. So means what happens when a light ray travels from denser medium to rarer medium means it will bend away from the normal. So the light rays means these light rays will bend away from the normal and reaching. Any light ray coming from this straw is reaching in this direction like this, they are reaching us. So our naked eye will feel that the light rays are coming from here. So we are thinking that the straw was here. The straw is here. The straw appears here even though it was here. Now note the angle between outside straw and the normal, which is called angle of refraction. Note the angle between outside straw and the normal, which is called angle of refraction. So take the table used in the lab activity 1. So now take the table. So in the table, see what I am taking. So angle of incidence I, angle of refraction R. So I am finding angle of sine angle of incidence and sine angle of refraction we are taking. So fine. First, what's the angle of incidence we have taken here? So angle of incidence we have taken here is 10 degrees. And the angle of refraction we get some value which is greater than 10 degrees we get some value. So now note down those angle of incidence and angle of refraction in the table. Do the experiment for different angle of incidence, means this straw, next time you keep it for 20 degrees, 30 degrees, like keep this straw for different angle of incidence and note down the corresponding angle of refraction. Observe the corresponding angle of refraction every time and note down them in the table. So first incident angle I, one corresponding refraction angle. Now adjust the straw with some other angle, that is the first straw, 20 degrees. Note down the corresponding refraction angle. Repeat this for different angles. And we should not do this activity. We should not do this activity for an angle of incidence more than 48 degrees. Because critical angle for water and air is 48 degrees. So we should not keep this straw, the straw inside the water, we should not keep at an angle more than 48 degrees. Don't take up this straw at an angle more than 48 degrees. So the reason we will come to know in the next coming concepts, that is in the total internal reflection, we will come to know. Okay, fine. So what do we observe, my dear students? See, if I take angle of incidence 10, I will get particular angle of refraction which is some 15 degrees. If I take this is 20, I may get 25. And if I take this angle 30, I will get here 35 degrees. like this is an every time. So in all the cases we will find that, so we will find that angle R is greater than angle I. So that is when a light ray travels from denser medium to rarer medium. So the light rays bends away from the normal. So denser medium to rarer medium, when a light ray travels from denser medium to rarer medium, at the interface surface it bends away from the normal. So we can write the result. When a light ray travels from denser medium to what is that? Rarer medium. The light ray travels from denser medium to rarer medium. At the interface surface, it bends away from the normal. Traveling from denser medium to rarer medium, so it bends away from the normal. It bends away from the normal. That is, in all the situations, angle R is greater than angle I. So in all situations, angle of refraction is greater than the angle of incidence also. So we got it. Okay. And from this experiment, and now see, my dear students, so conclusion we have given. What happens from this experiment? We can conclude that when a light ray travels from denser medium to rarer medium, so when a light ray travels from denser medium to rarer medium, it bends away from the normal. It bends away from the normal, and also we can say that angle R is greater than angle I. So this is also important result we are getting. And next one we can say that when a light travels from one medium to another medium, so the ratios of V1 by V2, the ratios of V1 by V2 is equal to the ratios of N2 by N1. So when a light ray travels from one medium to another medium, it follows the ratios of V1 by V2 must be is equal to N2 by N1. And also the light should enter into a medium in such a way that, so the light should enter in, so when the light ray going from water to air, it enters from water to air in such a way that the ratios of sine of angle I and R, the ratios of sine of angle I and R, that is sin I by sin R ratio is equal to V1 by V2. So it will follow in this manner. When it is entering from one medium to another medium, it follows the rule that the ratios of sin of angle I, sin of angle I sin of angle I and angle R, sin of angle I and R is equal to V1 by V2, and it is, and from this equation we know that V1 by V2 is equal to, so we can write that N2 by N1 also, and this is one result we can get it. So, and see, first strong we adjusted for a particular angle 10 degrees, and its corresponding refracted angle we have measured, some angle we measured, and we know this R is greater than I. You will get some angle, that is some 15 degrees, roughly I am writing 15 or 20, some angle you will get it. So now I know so by using Snell's law I can calculate the refractive index of this water. I can calculate refractive index of this water. I will calculate. So you can see that. Please wait until the concept. Now, so in this activity we have concluded that when a light ray travels from denser medium to rarer medium, it bends away from the normal. That is, for every angle I, you will get angle R greater than I, and these ratios becomes constant. And from the following experiments and activities, means that is lab activity 1. The lab activity 1 we have discussed. From the lab activity 1 and these activities, we can conclude that refraction of light follows certain laws. Refraction of light follows the during refraction of light, it follows certain rules. During the refraction of light, it follows certain rules. Those are called laws of refraction. From the lab activity 1 and the activity number 4, from these activities we can conclude that during refraction of light, it follows certain rules which are called laws of refraction, which are very important. So now I am going to write the laws of refractions. Laws of refraction of light. So laws of refraction of light. The first law is the incident ray. So since we are looking this straw, so the light rays are coming from this straw. So this is the incident ray, the refracted ray, and the normal at this point of incidence. So if I call this is some A, and this point if I call O, and this point if I call some B, incident ray AO, refracted ray OB, and this is the normal I get that is called N and dash. So the incident ray AO, incident ray AO, incident ray AO, refracted ray OB, so that is refracted ray OB, and the normal N dash at the interface. So normal N dash, this is the normal N dash for this interface, N dash at the interface of two different media, at the interface of two media lying in the same plane. This is very important. So what is the first law? See, my dear students, the incident ray AO, the refracted ray OB, and the normal all will lie in the same plane. Lies in the same plane. Incident ray AO, refracted ray OB, and the normal N dash lying in the same plane. Means if we take out this protractor and we'll put one paper, all are lying on the plane only. That is called paper. They are touching on one paper only. So fine. So that is about the first law of refraction. And second law, it is very important for doing the problems in chapter number 3. So second law is called Snell's law. Second law is called Snell's law. So first law we have seen, and second law Snell's law. Snell's law means N1 into sine of I. So N1 into sine of I, sine angle of incidence, is equal to N2 into sine angle of refraction. So that is equal to, so N2 into sine of refraction, that is equal to constant. So this is called second law, which is very important. So what is that, my dear students? See, so for a particular medium, so here this medium refractive index into what angle you have, take the sine angle of that, sine of this angle into its refractive index. This product must be same as that of this product must be same as that of sine of angle of refraction into this medium refractive index. So that is N1 into sine of I. Means I can call this is light ray first started here, now I can call this is N1. Okay. So that N1 into sine I is equal to N2 into sine R. That is equal to constant we can write. So this product is same as this product, and this product for a given plane of medium, refractive index into what angle you have here, refractive index into sine of that product angle, always constant. Or this can be written as sine I by sine R. So this can be written as sine I by sine R. R you find a denominator, sine I by sine R you get N2 by N1, and from the relative refractive index concept you know N2 by N1 is equal equal to n221, which is equal to constant. Because refractive index is a constant, you know. So sin I by sin r equal to constant. You can also simply say that sin I by sin r equal to constant. So this is called Snell's law. In the broader sense, in the clear sense, we have to say like this. So n1 into sin I is equal to n2 into sin r, that is equal to constant. Or sin I by sin r is equal to constant, you are writing. So this is the second Snell's law. So light follows, during refraction, light follows the laws of refraction. First law we know. So incident ray, refracted ray, normal, all will lie in the same plane. This board is a plane. They will lie in one plane only. Paper is a plane, board is a plane. Any smooth and flat surface is a plane. So fine. And second law is called Snell's law, and that also we have seen. So this is means when a light passes from one medium to another medium, in order to pass from one point to another point between those two mediums, to go in a least possible time, the ratios of sin I by sin r must be equal to n2 by n1 equal to constant. We should write. And in this activity, we know, my dear students, we know here I, because this law we set for particular angle. We know the value of I we know, and we know the angle of r. We are getting r value. So because by setting this strap. So we know I value, we know R value, and we know this refractive index. This refractive index, this A refractive index, refractive index of the A already we calculated in our first concept. So that n suffix A value 1. So I can calculate this by using Snell's law. If I know I value, R value, and this refractive index I know, I can find out this refractive index by doing this experiment. So because here I have four variables, n1 sin of I, n2 sin of r. So if I know n1, I know n1 means I can call this as n1. Your wish, n1 into this product. This I know, and this angle I know. This I am going to calculate. So out of four variables, any three variables are known. We can make the fourth variable unknown as a known. So that is about lab activity 4. Thank you all.